And welcome everybody to the Daily Space Weather Show. Everybody will be talking about the corona mass ejection that's headed Earth's way, so it's 2 in a row. Let's get to that. So we've taken some custom videos here. These are only 7-hour videos. So you can see that a bunch of limb darkening is happening there around the South Polar region toward the end of the video. Also some Hyder flare activity, which is right in this area, as you can see. Some plasma splashing back down, but the big story will be the filament that rose up from the sun's perspective. And it's coming down from your perspective because a large portion of that is headed in Earth's direction. So exciting news for aurora chasers and space weather enthusiasts in general. You can also see some cool filamentary activity going on up here. We didn't even really worry about that too much because we're more interested in the one that is headed toward Earth. So here are some more custom views. Again, these are only 7-hour videos, or I think they're actually 6.5, 8:30 until 1500. Here's an extreme close-up of the area from which the filament originally erupted. And that is at 1/3 of the normal speed we usually play. We usually show 30 frames per second. That's down to 10. There, it's now at 15 frames per second, I believe. And I think I just got spammed. Anyway, here's the southern polar region. Once again, down to 10 frames per second. Some of those plasma filaments taking several hours to make their way out of the corona. Some of that material might have even started splashing back down again as well, or just stayed in the corona. Another possibility. So great view of that. Here's that's the 15 frames per second version. 8:30 Universal Time on January 20th, 2024 until 1500 UT. And once again, there's the full disk view that same time frame. The wavelengths are 304 angstroms ionized helium and 193 angstroms ionized iron. And we'll get to some more of that here in a moment. First, a brief look at sunspots. And we had some significant growth in that northern group, as well as the group south of the equator on the eastern quadrant. Besides that, mostly stable, it looks like to me. There is colorized magnetogram. And before we talk about anything else, let's talk about the changes that happened today on the channel. So they happened a little bit silently, and Eugene the Philosopher, our largest contributor, make sure you go subscribe to his channel, has been doing Friday segments for us, the Ask a Particle Physicist segment. So if you'd like to submit questions yourself, we'll get to that in a moment. Again, make sure you go subscribe to Eugene the Philosopher. And we've linked to the playlist, the Ask a Particle Physicist playlist. There are now 8 videos in there available to everybody, except the Smash team, which gets yesterday's video separately as well. So we have the Ask a Particle Physicist segments separated, and here's a brief segment from the first one. Solar protons, what do they do?
We're gonna get in, okay? But the more complicated answer, it seems like it does get into this polar cusp areas, right?
So there, go have a watch. And if you'd like to submit questions yourself to the Ask a Particle Physicist segment, head to smashomash.com/forum, and you can do just that. So that's the best place to do it. We do take questions from anywhere, but you know the best place is on our forum, not in like YouTube comments where it's, you know, we'd prefer to rely on our own servers than YouTube servers. I'll just say that. And so, yeah, so let's get to volcanoes briefly here before we get back to space weather. These are the erupting issues right now. We've got Indonesian activity, multiple, like 4 volcanoes in Indonesia. Not sure about Popocatépetl. Guatemala, Ecuador, and Peru, all featuring erupting volcanoes. Next, earthquakes. And we had 2 6+ magnitude quakes. The largest was in the rainforests of Brazil. So talk about an unpopulated region. There's where this 6.5 magnitude quake happened. Looks kind of like the middle of nowhere, folks. That's the satellite view. There's the topographic map. That is indeed a rural area. So yeah, there's a location of that quake. Again, a 6.5 happening there. We'll get to it. Here are the 5 and greater magnitude quakes for the past 24 hours. Alaska seeing a series of quakes. So no 5 or greater magnitudes, though. India had a 5.0. Pretty much seismic activity here in the past 24 hours. 5.0 at India. at the South Sandwich Islands. 5.2 at New Caledonia. About a half hour after that. And then what's next? A lull in activity. And then Mariana Islands region had a 6.1 at quite deep, 184 kilometers. And then Brazil, look at that. 628 kilometer depth quake there at Brazil, and now a 6.3 at the southwest Indian Ridge as well. So major seismic uptick happening here. Hopefully none of those quakes are foreshocks, folks, because if those are foreshocks, big quakes loom on the horizon. And before we get to that, radio flux and so on, let's show some additional imagery here. So these are 24-hour videos now, same wavelengths, 193 plus 304 SDO. And here we'll zoom in to show the equator. Note that filament moving around there in the northeast as well. Your upper left screen, that did lead to a coronal mass ejection, as well as a filamentary reorientation. Some of that filament there moved around but is still attached. Here's 304 angstroms. Full disk view, 24-hour, 30 frames per second, folks, which is the normal speed we use on the channel. And before we get to that, let's talk about some stats. Yes, the 10.7 is at 166. I think it's at 166. There you go. That's the 1 year chart. There you go. 166 is the F107, the 10.7 centimeter radio flux. Red line is the sunspot number. Black line is this radio flux for the past year. And yeah, there you go. No space weather storms forecasted by NOAA here. We could see some arriving as early as late in the day on the 22nd, more likely on the 23rd. So 2 CMEs on the way. The second one could cause some significant geomagnetic storms. So we'll get to that. First Earth magnetic moment from space for the past 4 hours. There you go. It's our Geospace Magnetosphere movie. And it's geomagnetically calm, folks. Geomagnetically calm. Ground magnetic perturbations. Now, there will be some aurora visible in the usual suspect locations. Nothing major, although we might see some significant geomagnetic storms from that CME, which we will cover in greater detail here later in the video. But that's what's going on at the ground level. Magnetic perturbations, changes to Earth's B field, or geospace delta B. KP index is at 1. Again, geomagnetically calm conditions are what we've got. Next, solar wind. And slow and low at the ACE. A little faster, but also pretty diffuse at the Discover. So the Discover only 4.25 protons per cubic centimeter, 393 kilometers a second for the velocity. Goes magnetometers, quite smooth. Expect to see some big perturbations in that when the coronal mass ejection arrives, as plasma attempts to reach static equilibrium. So Earth also has snapped into a South Pole-oriented magnetic heliosphere sector, shown there in red, showing the magnetism of the ecliptic plane. So, welcome to the South Pole magnetic heliosphere sector, folks. Next, the solar B field, photosphere magnetism, and of course, polar fields. Our line of sight field plot. Next, coronal holes, which I didn't load for some reason. There we go, coronal hole line of sight plot. We've got South Pole oriented coronal holes rotating in. So here are those from SDO. Another 24-hour video. And before we get to sunspots, let's pause for station identification. You've reached the Smash News Network least busted name in news. Sunspot number is at like 128. 128 is the sunspot number. Likelihood of large flares is, well, it's gone up since yesterday because 3559 is looking magnetically complex to me. I like it. 3559, folks. That is the new sunspot to watch. By tomorrow's Daily Space Weather video, that one's going to be our T-mass, the most active sunspot. T-mass, the most active sunspot. Let's look at sunspots, first in the magnetogram, then the SDO continuum. And then that's not close enough. There we go. That's a little better. So the dip in sunspot number since yesterday was a result of setting groups in the west. We've got a lot of groups that have risen and formed in the east. So, let's see. Not sure. We're going to see a relatively flat sunspot number going into tomorrow unless we see continued growth. Oh, we're seeing some growth out here as well. In fact, an entirely new group has formed right there. So that's multiple new sunspots. I don't know. I'm not going to get into counting them, but there you go. That's the past 24 hours. You be the judge. And remember, folks, one important thing to understand about solar maximum is that at solar maximum, you get sunspots at all active latitudes, which is like this entire area can have sunspots. At solar minimum, they only show up around the equator. But at solar maximum, they show up at all latitudes. So you can expect to see approximately a year and a half of this level of activity, average, as we ramp up and up and up to solar maximum. Now, we did have a tiny spike in the GOES proton flux, so a little bit of energetic particle event there, some relativistic particles. The tiny spike there in the greater than or equal to 10 million electron volt proton fluence. X-ray flux has been minor. 2 C-class events are really all that we saw. They were associated with coronal mass ejections. Let's take a look at flares through 94 angstroms. So up there in the northeast, that has already been the most active sunspot, so it is our T-mass. Well, I guess this one down here that's a bigger flare, I guess. I guess this southern one is actually the T-mass. But my favorite for future flares is still that northeastern one, this one up here. And let's take a look at a star chart. So that's what's going on overhead Lehigh Valley. Actually, not that, but that. Just press the Now button once you've programmed in your location at skyandtelescope.org's lovely star chart. You got the moon and Jupiter up there. Two of the brightest objects visible from the earthly skies. Next, our solar system forecast. Here's the 1 week. That's where things will be on the 27th. And look, folks, Earth will be out of conjunction with Pluto, and thank goodness. Oh, noes. I was so spooked when Earth was in conjunction with Pluto. Oh, dear God. Next, our astronomy photo of the day, and check this one out. This one is, I don't know, it's not really astronomy, but it's all right. It's Falcon boosters. Falcon SpaceX rocket boosters doing their separation burn to return and become reusable. Yeah, there you go. So some fantastic technology there. Reusable rocket boosters, folks. That is part of how they get them back, by not having them smash into each other. The boost back burn by the Falcon Heavies. Next, CMEs, and it'll definitely be a subject to cover today. So stop your grinning and drop your linen. Whatever the hell that means. You may see a CME there that looks like a halo. And indeed there is. That is an Earth-directed coronal mass ejection, our favorite kind. That's 80 frames from today, January 20th, 2024. We'll also show the LASCO C2 and C3. Here comes the halo, and there it goes. Very nice. Here's a little closer view before we get to our custom coronagraphs. Yes. Earth-directed CME, expected to arrive late in the day on the 23rd. Here come our custom coronagraphs. And how fantastic is that? Really, there's 3 events happening there. There's one out of the north, there's one out of the northeast, and then there's one out of the nearly central disk. That central disk one is, not surprisingly, the one that is headed toward your back door. What is happening? How is it not playing? Dear God. There we go. That's 24 hours at 30 FPS. And it looks like indeed part of that CME did remain on the sun, but a large part is headed toward Earth, just the way we like it. No, it's not going to end civilization. You'll be just fine. It's not a reason to get in your bunker. It's likely a reason to go out and try to see the aurora when it shows up. So stay tuned to the channel for future calibrations of the expected impact time. And here we are, back to that CME. So great example of multiple things happening there. Some minor flaring, coronal mass ejection, and also a hider flare, which is the brightening after the CME as some plasma succumbs to gravity. Now, there are a massive number of filaments on the Earth-facing portion of the solar disk, so let's don't overlook that. Here come filaments, and it's a big deal. So all those dark absorption features there, those can become coronal mass ejections, and some of those are absolutely massive. So they could definitely use names. If you want to name them, follow the hashtag name that filament, name them after your friends, your foes, or even yourself. At X, yeah, Twitter is what I mean, x.com/smashomash. We'll let that play through, and then we'll stop at the last frame, because it's time to do a filament count. So we'll start over at these. These are the least interesting. 1, 2. This one's already named. That's 3, 4, 5, 6, 7, 8, 9, and we'll say 10. So, but this one right here especially, that one is a prime specimen. That is a solar filamentary smiley face if I ever saw one. Very nice. The solar smirk. Anyway, before we get to bonus features, there's a CME going on there right now as filamentary activity occurs in the northwest and the south solar polar region, also showing a prominence. So you can expect more and more exciting stuff in the coming 18 months. It's a great time for space weather. And let's get to bonus features, starting with charging hazards. We don't have any. It's smooth sailing. The GOES electron flux here is just in a very low range still for an extended period of time. Check it out. The last 7 days just pretty much cratered almost the whole time there. There you can see the biggest electron shortage in the past year. Those are measured at the F layer of the ionosphere, by the way. There's the forecast, and expecting for a continued low level of electron flux. But there are some new electrons that are going to be on their way up there shortly. Next, the layer where it's measured. The F layer of the ionosphere. It's at 300 kilometers of altitude, and here it is. That is the raw vibrational frequency of the F layer. Here's the anomaly in megahertz from a 30-day median of the F layer. In many ways, the F layer of the ionosphere is the bridge between Earth and space. Not to be confused with the D layer, which is the layer that is associated with your radio propagation, which we will show you here momentarily. There you go. Maximum usable frequency on the right. Total electron content on the left, along with anomalies for each. We'll close out space weather after that plays through with the high-res images. And remember, folks, never attempt to sneak up on a dragon in its lair. You will fail, and you will not surprise it. There are the latest images of the closest star. Again, I kid you not, this sunspot is the one to watch. It's Beta Gamma Delta class, our favorite kind on the channel. Next, we're taking a look at total cloud water. Yeah, there's a bunch of water. It's the Pineapple Express, and it's making it kind of moist over on the left coast. So there is total cloud water and surface winds, and you can see the delivery of a lot of moisture, followed by a second wave of moisture. It's the Pineapple Express. It's the Bonsai Pipeline. It's the hydrosphere. It's the water cycle. Did you know that some of Hitler's urine could be in that cloud water? Some of Hitler's urine could be in there, folks. I mean, just think about that. That is... Now I'm spooked of rain. I'm going to have to spend a year or two in the bunker eating MREs. Anyway, here are surface winds for the eastern world. Here are the jet streams. Jet streams of the central world there. There you go. Here are the surface winds of the central world, and we've detected some of Hitler's urine in the Mediterranean Sea. Not too surprising. Next, the western world. There are the surface winds, and there are the jet streams. Remember, folks, not every raindrop that you dislike is necessarily Hitler's urine. All right, so moving right along, here are the clouds and fog over the Americas. And today we've got a special feature since we're talking about the left coast and the Banzai pipeline. There you go. There is that moisture being sent your way again and again via the jet stream. As a low moves up the Oregon coast. Ah, yes, the Eastern Pacific. So check it out. There's some heavy rain coming. 5.45 inches coming to places in Northern California. So there's the next 12 hours of rain, 24 hours, and there are 3 days. That's the Euro model. Here's the GFS model showing even more rain on the GFS model. More concentrated patches on the Euro model. That's the next 3 days of new rain. These are the next 3 days of new snow GFS. And the next 3 days of new snow on the Euro model. Next, weather.gov. Weather.gov is where to get your weather warnings. If your location is lit, click it at weather.gov. Lots of warnings there for Hawaii and California and some very cold warnings. Here comes some forecasts, starting with the GFS 72-hour pressure and precipitation. I told you there were multiple waves. Here's a total accumulated precipitation forecast in inches based on the GFS 72-hour model, and some heavy rains coming to southern Texas as well. 4 inches of rain coming, and more for parts of California. Total accumulated snow depth change in inches. 72-hour GFS model. Some heavy snow there coming to northeastern California. Last but not least, temperature anomaly in degrees Celsius based on the same model, the GFS 72-hour. Next, lightning. South America's got a lot of it. North America ain't got jack. Here's a real-time lightning map from lightningmaps.org. And today it loaded. Oh, it's very light on lightning right now. Only like 10 strikes per minute. That's a very low number. Next, U.S. Doppler radar will briefly show the 50-state view. And then we'll focus on the lower 48 view. So that's what's going on. A bunch of lake effect snow there, especially east of the Great Lakes. Clouds and fog are next. And last but not least, water vapor. You can see a great view of that low moving up the Oregon coast. Next, a recap. Ground-based Doppler radar systems, they show vertical motion in the air column. If they're calibrated right, they'll show you when precipitation is reaching the ground. That is fog, rain, snow, and sleet. Next, clouds and fog. Satellite-based systems depicting 3.9 micrometer infrared radiation. And finally, satellite-based systems depicting 6.19 micrometer infrared radiation, showing you the water vapor. And that is where to close this thing out. As the moisture makes its way across the Rockies, I'm signing off. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, and may that solar wind be at your back.